Welcome to the 2020 Math, question 1C. The question asks us to find what the sum 1 minus 4 plus 9 minus 16 plus ... plus 99 squared minus 100 squared is equal to. It gives us the option A, minus 101, B, minus 1000, C, minus 1111, D, minus 4545, or E, minus 5050. Pause the video and have a go at doing this for yourself. Okay, let's begin by calling this sum S. And what do we notice about the sum straight away? Well, we can see that these first four terms are the first four square numbers, so we can rewrite them as 1 squared minus 2 squared plus 3 squared minus 4 squared. And that gives us a better idea of what this ... represents. We're continually adding on the next square number and then subtracting one away. So now that we've written it in this form, does this remind you of anything? Well, we can see that if we group the terms of the sequence into pairs as we go along, then we just have the difference of squares at each stage. So we can use the difference of squares formula, which is that a squared minus b squared is a plus b times a minus b, in order to rewrite this sum as 1 plus 2 times by 1 minus 2 from these two terms, plus 3 plus 4 times 3 minus 4 from these two terms. And then from the next two terms, we'd have 5 plus 6 times 5 minus 6, and so on, up until we replace this last term with 99 plus 100 times by 99 minus 100. So you might think that this has just made everything more complicated, but we can notice that the second one of all of these brackets is always equal to minus 1. So if we evaluate everything inside the brackets, we see that S is equal to 3 times minus 1, plus 7 times minus 1, plus 11 times minus 1, all the way up to 199 times minus 1. And therefore, we can factor out this minus 1, and we're just left with the sum 3 plus 7 plus 11 plus 199, and we need to evaluate this sum. So how can we do this? Well, we can notice that this thing inside the brackets, if we ignore the plus signs, is an arithmetic sequence, because each time we are increasing the terms by 4, and this will carry on all the way up to 199. So how can we find the nth term for the sequence 3, 7, 11, and so on? Well, we take the term-to-term difference and multiply this by n for the nth term, and then since the first term is 3, this will be tell us that the formula needs to be 4n minus 1. So that's the nth term formula for the sequence 3, 7, 11, etc. What term of the sequence is 199? Well, if 4n minus 1 equals 199, then 4n must be 200, so n must be 50. So this sequence is this sum is the terms of the sequence 4n minus 1 for n between 1 and 50. So now that we have an nth term formula for the sequence that we're summing up, we can write it with sigma notation as the sum from n is 1 to 50 of 4n minus 1. And remember, s is equal to the minus 1 times this sum. So how can we evaluate this sum? Well, we can split it into two separate sums if we expand out this bracket, which is minus 4 times the sum from n is 1 to 50 of n, and then the sum from n is 1 to 50 of 1, where this minus 1 and this minus here have cancelled out to give us a plus. So how can we evaluate these two terms? Well, the first one we can use the triangle number formula, which tells us that this is equal to a half times 50 plus 1. And for the second term, we're just adding 1 50 times, so we just get 50 times 1, which is 50. So this is what we find for S, and then we can multiply everything together in this first collection of numbers here to get minus 5,100, and then we add on 50, and so overall that gives us minus 5,050. So if we look back at the options in the question, minus 5,050 was option E. So we can therefore conclude that the answer to the question is answer E.